So now that we have explored the vertex form of a quadratic function, we are ready to establish the vertex formula for a quadratic function in standard form, or f of x is equal to ax squared plus bx plus c, where of course a cannot be equal to 0. So the coordinates of a vertex, or the coordinates of the vertex for a function in standard form is defined as follows. So the coordinates of a vertex are defined as x is equal to minus b by 2a, and then we take that x coordinate and substitute it back into the function to find the corresponding y. But where does this formula come from? So in order to establish the coordinates for the vertex, we need to go ahead and complete the square on the quadratic function in standard form. So let's take a look. Now, remember, when we're completing the square of a function, we need to have a leading coefficient of 1. So let's begin by separating this trinomial into two parts and then pulling out that factor a. So we can rewrite our quadratic in standard form by separating the first two terms, ax squared plus bx, and we'll keep that constant c on the outside for now. So here, again, in order to complete the square, we need that x squared to have a leading coefficient of 1. So we begin by factoring it at a out in front. So this can be rewritten as a multiplied by x squared plus b by a times x plus that constant c. So now we've set up that perfect notation to go ahead and complete the square. And recall that to complete the square, we're going to think about the coefficient attached to the variable of degree 1. And to complete our square, we are going to need to add and subtract half of this coefficient squared, or b by a, all divided by 2, squared. And the reason that we're adding and subtracting it simultaneously is so that it's like we're doing nothing to this function. So we can rewrite this expression as a multiplied by x squared plus b over a times x. And here's the completing the square part. We are adding half of the coefficient b by a squared. So we can say that we're adding b over 2a squared. And since we're adding, we also need to go ahead and subtract this. So minus b over 2a squared. And don't forget that plus c on the outside still. All right, so at this point, we're ready now to think about this trinomial. This is where the square of the binomial is going to come from, or the perfect square. Now, before we rewrite this as the square of a binomial, let's simply simplify a little bit to make this look nicer. So we can rewrite this as a multiplied by, so here's that perfect square in its trinomial form, x squared plus b over ax, plus I'm going to rewrite this as b squared over 2 squared, which is 4, times a squared. And then on the outside of that trinomial, don't forget we still have this minus b squared, all divided by 4a squared, and plus c on the outside. So now that we've simplified, we can go ahead and factor this trinomial. So in factoring that trinomial, we can really appreciate the square of the binomial, and we're starting to see the vertex formula come into life. So we can further rewrite this as a, and this is all multiplied by x plus b by 2a squared, and we have a minus b squared over 4a squared plus c. Now, to actually rewrite this so it looks like the vertex form of the quadratic function, we now want to go ahead and redistribute this factor a. So when we redistribute a, we can rewrite this now as a multiplied by x plus b over 2a squared. Then we have minus a multiplied by b squared over 4a squared plus c. So we can see the x component of the vertex. And let's just simplify our constant a little bit here. And we notice we have a common factor of a. So this a will cancel with one of the a's in the denominator, leaving us with the expression a multiplied by x plus b over 2a squared. And now we have minus b squared all over 4a plus c. And if you want, you can take this and rewrite this as a single expression by finding a common denominator. So we can think about c as being over 1 and multiply the numerator and denominator of this by 4a. So last but not least, here we have the coefficient, or the leading coefficient a multiplied by x plus b over 2a squared. And now because the second term here is positive, I'm going to pull this to the front and say that this is going to be plus 4ac minus b squared all over 4a. So even though this looks a little bit more exciting than the vertex form, we can see here that this is in fact the vertex form. We have that leading coefficient of a times the binomial x minus h squared. So in this case, the x-coordinate of the vertex is h is equal to minus b by 2a plus your constant c. So this is our constant c in this case. So this is allowing us to see the components of the vertex, xy, where x is equal to minus b divided by 2a, and y, or h, or excuse me, k, is going to be equal to 4ac minus b squared, all divided by 4a. Now, this looks a little bit exciting, a little bit too complicated. So to make this easier on ourselves, we simply rewrite this as minus b over 2a. And we say we're going to take this x-coordinate and substitute it back into the original function to find that same y.